series method to solve first order differential equation. Amen. What you help me do, just follow me, subscribe, make sure you share it. Thank you and God bless you. Okay, assuming we come across an equation of this form, says solve, amen, solve y prime minus y is equals to 0. I know very well that as you come across something like this, you get confused. How can you solve something of this form? This is the first order differential equation. So what we will do, let's write solution. Amen. Solution y prime minus y is equals to 0. Amen. Okay. You know, in differential equation, sometimes instead of dy all over dx, they use y prime. Amen. So it implies that this is the same thing as y prime. So please take note. Are you following? So now, this first order differential equation, we can use analytical method to solve this first order differential equation, and we can also use power series method to solve this differential equation. I'm going to show you the analytical method. Okay, let's write. Let us convert this to reduce this or transform this to this form. Now write note that amen, y prime is equals to dy all over dx, true of us. Okay, so if you agree with me, it means at this point, instead of this, we are going to substitute in this our dy all over dx minus y equals to 0. So what we will do, we take this y to the right hand side, all over dx is equals to y. Amen. So if you can see what I am saying, amen, if you can see what I am saying, it means we are going to use what is called separation of variables, separation of variables. Amen. We will apply separation of variables. Okay. So if you agree with me, it implies that our dy is equals to, we cross multiply y dx. Amen. So if you agree with me, it means before we can integrate both sides, we must divide through by y. If we divide through by y, divide through by y. Amen. Divide through by y. Divide through by y. If we divide through by y, we have dy all over, y, isn't it? Equals to y cancel. We will be left with what? Dx, two of us. So what we need to do is for us to integrate both sides. Now we write integrating both sides, okay? Integrating both sides, amen. So here we are going to have integral dy all over y equals to integral dx, amen. Okay, so if you agree with me, if we integrate the left hand side, we are going to have, that is, if we integrate in 1 all over y, we will have in y, amen, in y plus a constant. Let us assume this one to be k1. Then integrate the right hand side, we are going to have what? If we integrate dx, we will have x plus k2, because already we have used k on the left hand side, k1, so this one will be k2. Okay, so now in y is, we collect like terms, is equals to x plus k2. This one crosses the sign of positive because minus k1. So what we will do is we assume setting k2 minus k1 equals to k. Right, putting k2 minus k1 equals to k. Do you agree with me? So it implies that instead of k1 minus k2 minus k1, we write k. So our in y is equals to x plus what? Sorry, x plus k. Amen. Do you agree with me? Okay. So if you agree with me, it implies that let us take in on both sides or take log on both sides. It means if we take log on both sides, we are going to have the left hand side will now be y exponential x plus k, true or false. Okay, so if you agree with me, we are going to apply indices in the right hand side. Let us apply indices on the right hand side. Note that, amen, note that our exponential x plus k, this is the same thing as exponential x dot exponential what? K, true or false? So please take note. So if you agree with me, so here we are going to do it this way. Y is equals to exponential x dot exponential k, true or false? So if we putting exponential k equals to c or any alphabet, this implies that our y is equals to c exponential x. This is the final answer. This is the analytical method which we can use to solve this first order differential equation. So now, I mentioned to you that we are going to use two methods, using analytical method and power series. So now let's look at power series method. Amen. Okay, let's look at it. Any question? No question? Okay, let's look at it together. Okay, let us take off, clean this part. Let's clean this part. Okay, so far so good. Let's look at it together. Okay, so the power series method will now say let us assume let y of x is equals to the sum of n equals to 0, running from 0 to what? Infinity, then a n x raised to the powers of n, which is equals to a naught plus a1x plus a2x squared plus a3x raised to the power of 3 plus plus a4x raised to the power of what? 4, then plus a5x raised to the power of 5, and plus plus amen. You can continue. It's okay. So let us just stop here. Okay. So if you agree with me, it implies that in this differential equation, first order differential equation, you discover that it is a first order differential equation. It means we are going to differentiate this series once and substitute into this original equation. So let us differentiate this series. If we differentiate it, it means y prime of x is equals to summation. Now your n will now be equals to 1 because of you are differentiating it once, 1 to infinity. Then this will be what? It will be, it will be n x raised to the power of n minus 1, true or false? Then let us differentiate this. It means this will give us, if we differentiate a naught, here will be 0. If we differentiate a1x, here will be a1, isn't it? Then plus differentiate a2x squared will give us 2a2x plus differentiate 3al, a3 x raised to the power 3 will give us 3x raised to the power of 2, true or false? Then differentiate 4a x raised to the power 4 will give us 4a4. Sorry, this is a4 x raised to the power 4 will give us this. Then differentiate a5 x raised to the power of 5 will give us 5, amen, a5 x raised to the powers of what? 4 plus amen. Okay, so this implies that our y prime of x is equals to what we need. We just need to use this. It will be equals to a1 plus 2a2x plus 3a3 x raised to the power of 2 plus 4a, sorry, we do not put x here, raised to the powers of what? 3, isn't it? When we differentiate this, it will give us this, sorry, take note, okay? X raised to x, 4a4, x raised to the powers of what? 3 plus 5a5 x raised to the powers of 4 plus amen. Okay, so what we will do here is for us to substitute this y prime into this equation. So let us recall that our y prime is y prime minus y equals to 0. So anywhere you see this y prime, you write this equation. Then recall that our y is equals to this, two of us, this first series. So note also that amen, our y is equals to a1 naught plus a1x plus a2x squared plus a3 x raised to the power 3 plus a4 x raised to the power 4 plus a5, amen, x raised to the powers of 5 plus amen. Okay, so what we will do here is for us to substitute in this and this into this equation. Let's do it together. Okay, let me write it here. Let's write it here. Okay, any question? No question? It's okay. Okay, so if you agree with me, it implies that y prime minus y equals to 0 will now be, let us have a1 plus 2a2x, amen, plus 3a3x squared plus 4x raised to the power of 3, amen, and plus 5a5x raised to power what? 4, sorry, this is 4, x raised to power 4. Then what we have here is minus. So we write minus, amen. Then we put bracket here so that the bracket will affect the whole of y. If you don't put bracket here, you won't arrive at the answer. So that this minus sign will affect the whole of this y. So our ordinary y is now what? a0 plus a1x plus a2x squared plus a3x raised to the power 3 plus a4x raised to the power of 4 plus a5x raised to the power of what? 5. I know you are kind of worried because of this Yes, you can put either plus here, even this one too, you can also put here. But it's not necessary. Is that clear? It's not necessary. We just stop here. So what we need to do is for us to open this bracket. So our a1 plus 2a2x plus 3a3x squared plus 4a4 x raised to the power of 3 plus 5a5 x raised to the power of 4. Then multiply out, here will be minus, isn't it? Minus a0 minus a1x, isn't it? Minus a2x raised to the power 2 minus a3x raised to the power of 3 minus a4x raised to the power of 4 minus A, sorry, we are supposed to put equals to 0. Please take note. Here we are supposed to put, because the equation is equal to 0. So we are supposed to put equals to 0. Take note, sorry. Okay? That is mathematics for you. So 5x raised to the A, 5 raised to the power of what? 5, which is equals to 0. Amen? Okay? So if you agree with me, it implies that we are going to equate the terms. You let us equate the terms. We know that A1 and A0 minus A0, they are in the same category, two of us. So A1 minus A0 is equals to 0, and this implies that our A1 is equals to what? A0, isn't it? If you make A1 the subject of the formula, this is how it will be. Then let us equate 2A2x then minus, yes. So 2A2x minus A1x equals to 0. So we know that if we do it this way, okay, we'll factor out the x, amen, minus A1 equals to 0. If we divide through by x, it will now be in this form, amen. So here will now be 2A2 minus A1 equals to 0. So if we make A2 the subject of the formula, we are going to have, let's have it this one first, is equals to, this one crossing the sign of equality becomes what? Plus, isn't it? So if you agree with me, it implies that our A2 is equals to A1 all over 2, true of us. But note that A1 is equals to A0. So this implies that since our A1 is A0, so we are going to substitute in, implies that our A2 is equals to A0 all over what? 2. Take notes. Do you agree with me? Okay. So let us equate this 3A3x raised to the power 2 and minus A2x raised to the power 2. So if you agree with me, this is A3x raised to the power of 2 minus A2x raised to the power of 2 equals to 0. We are going to do the same thing, factor out x squared. We factor out x squared, this is what we will have. We are going to have it in this form. So if you divide through by x squared, this is what we will have, 3A3 minus A2 equals to what? 0. Amen? Do you agree with me? So if we want to make A3 subject of the formula, this is how it will be. Our A3 is equals to, this one crosses the sign of equality, becomes plus A2, then divide through by 3, we'll have it A2 all over 3, true of us. But mind you, our A2 is equals to A0 all over 2. So instead of leaving it this way, we are going to substitute it with A0 all over 2. So this implies that our A3 is equals to, amen, okay, our A3 is equals to A0 all over 2, right? Since we are substituting in. Note that if we have something of this form, this is the same thing as A2 times 1 all over 3. Please take note. So we are substituting in for, instead of A2, we are writing A0 all over 2. So times 1 all over 3. True of us. Okay? So if you agree with me, this is the same thing as our A3 is equals to what? A0 all over 2 times 3, and A0 times 1 is A0, which is what? 6. True of us. Or, in other words, this is 3 factorial. True of us is the same thing as 6. Okay? So let us go ahead to equate Amen. Let's go ahead to equate. Okay, we are done with x. Let's consider x raised to the power 3. So it means we are going to have 4a4 x raised to the powers of 3, then minus a3 x raised to the powers of 3 equals to what? 0. Amen. Okay. So if you agree with me, if we factor out x raised to the power 3, we'll have it in this form, minus a3 is equals to 0. So you divide through by x raised to the power 3. This is what we'll have, amen, minus 3 equals to 0. What we need to do, we want to make a4 the subject of formula. We take this one to the right hand side, then divide through by 4. We are going to have it in this one. Our a4 is equals to a3 all over 4. Amen. Okay. Now, what is our a3? Our a3 here is a0 all over 3 factorial. True or false? Do you agree with me? So if you agree with me, instead of a3 here, we are going to substitute in a0 all over 3 factorial. So this implies that our a4 is equals to a0, amen, all over 3 factorial times 1 all over 4. True or false? Do you agree with me? So it implies that our a4 is equals to a0 all over 3 factorial all in bracket what? 4. It's the same thing. Do you agree with me? Okay. So if you agree with me, it implies that yes, let's consider a raised to the powers of x raised to the power of 4, because we are done with x raised to the power 3. Let us consider equate x raised to the power 4 plus 5a5 x raised to the power 4 and minus minus a4 x raised to the power 4. So we are going to have it this form. So let's let's come have it here. We are going to do it this way, amen. Okay, so here will be 5a5 x raised to the power of 4, amen. Then here will be minus a4 x raised to the power of 4 equals to 0. Amen. So if we factor out x raised to the power of 4, this is what we will have it inside the bracket. Amen. Equals to 0. Divide through by x raised to the power of 4. This is what we will have 5a5 minus 4a equals to 0. Then if we make a5 the subject of the formula and divide through by 5, we are going to have 5a5 is equals to plus a4 all over 5. Then let's recall what is our a4. A4 is a0 all over 3 factorial all in bracket 4. True or false? So instead of this, we are going to replace it with a0. So our a5 will now be equals to a0 all over 3 factorial all in bracket 4. Amen. Then times here is 1 all over 1 all over 5. True or false? So our a5 is equals to a0, amen, a0 all over 3 factorial all in bracket 4 all in bracket what? 5. True or false? Okay. So at this point, you discover that here we are at this point, isn't it? But when you look at this, we have 5a5 x raised to the powers of what? 5. There is nothing to equate it here, so we can stop here to get our solution by writing, amen, by writing, it means we will recall the original question, the solution. We'll say, no, we said let y equals to this. So let us recall that, amen, our y of x was equals to a naught plus a1x plus a2x squared plus a3x raised to the power 3 plus a4x raised to the power 4 plus amen, a5x raised to the power of 5 plus true or false. So now we are going to substitute in the values. You know, we've gotten our what? Our A1, our A2, A3, A4 up to A5. So anywhere we see our A1 here, we are going to substitute it by what we have gotten here. Is that clear? That is what we will do. And that will be our final answer. It's okay. So now our y of x is equals to our a naught is I will write it. This is our a naught plus what is our a1? Our a1 is equals to what? A naught. Then don't forget the x. So we write a naught x plus what is our a2? Our a2, look at it here, is equals to what? A naught all over 2. Mind you, don't forget this x squared. So we write it a naught x squared all over 2 plus what is our a3? Our a3 is equals to a naught all over 3 factorial, true or false? Okay, so mind you, don't forget this x raised to the power 3. So instead of a3, we write a naught all over 3 factorial. So a naught x raised to the power of 3 all over what? 3 factorial. Then plus a4, let's find our a4. a4 is this. a4 is equal to x naught all over 3 factorial, all in bracket what? 4. Mind you, don't forget x raised to the power of 4. Is that clear? So instead of a4, we write a naught, amen, all over a naught x raised to the power of 4, all over what? 3 factorial, all in bracket 4. Amen. Then plus a5. Our a5 is this, true or false? So our a5 is a naught, amen, x raised to the power of 5, all over 3 factorial, all in bracket 4, all in bracket what? 5, true or false? Then plus amen. Okay, so if you agree with me, let's do it this way. If you agree with me, ask yourself what is common. Yes, we are done. You can leave this one as the solution, no problem. But if you say you want to still move further, something is common here, true or false? We can factor out a naught, true or false? If we factor out a naught, it means this solution will now be, here will be 1, true or false? Here will be x, then here will be plus x squared all over 2. This one we can even write 2 factorial, no problem. But if you want to leave it like this, then here will be x raised to the power of 3 all over 3 factorial. Or if you want to write it times 6, no problem. This is 3. You know that 3 factorial is equal to 3 times 2 times 1, which is what? 6. No problem. Then plus here is 3 factorial, isn't it? X raised to the power of 4 all over 6, all in bracket. 3 factorial will give you 6, close bracket. Then plus what again? X raised to the power of 5 all over 3 factorial is 6, all in bracket 4, amen, close bracket 5 plus close the bracket. So this is the solution we are asked to look for. Any question? No question? what you will help me do is to share this video. Please try and help somebody so that the person will also appreciate you. Thank you and God bless you.